So you got a bit of introduction for me. My name is Armon Dadgar. For those of you who haven't met me, I'm one of the founders and CTO of a company called HashiCorp. You'll find me all around the internet as just Armon. So if you have any questions, follow-up, whatever, I'm going to post the slides later as well. Feel free to reach out. For folks who are maybe less familiar with HashiCorp, what we focus on as a company is sort of the kind of broad spectrum challenges in delivering an application. Right? So everything from talking to IT operators in terms of how do we think about provisioning infrastructure, where our focus is a tool called Terraform, to security and talking to folks like yourselves in terms of how do we secure modern applications, modern infrastructure, to runtime layers with Nomad, how do we schedule and deploy applications, to network connectivity. How do we connect and secure sort of how all of our services talk to each other? So as you might imagine, this sort of puts us at the intersection of security quite often, right? The intersection of all of these groups tends to be security. And so one of the things we look to do all the time is make security approachable, particularly for developers and operators who are sort of less versed. And I think a sort of common challenge that we face, and I'm sure many of you face, is as we talk about making security approachable, what we often get is something like this from our developers, right? Security is perfectly approachable to me. I just never think about it, right? What could be more approachable? And you know, we sort of laugh, but in some sense, this is sort of an all too common reaction among application developers. And so I think for me, the question is, you know, what enables this thinking, right? You don't get this when you ask developers about, you know, databases, right? They sort of have to be aware of databases. And so I think what this starts with is, what is the security mindset that we're applying, right? What is the security model that we're using to talk about what does our network security, what does our application security look like? And with any model, there's a series of simplifying assumptions, right? That's what makes it a model and not reality. And the model I think we're using today is transparent to developers, maybe by design, maybe by accident, but it enables developers to not think about it, right? And so when we talk about, you know, the model, you know, how are we thinking about security today? The analogy I like to use is sort of castle and moat thinking, right? And what I mean by castle and moat thinking is that it's very much a network perimeter-centric based model, right? We're going to wrap our data center in its four walls. We're going to bring all of our traffic, you know, ingress and egress over the drawbridge. And that's where we're going to deploy all of our fun favorite tools, right? We got firewalls and WAFs and SIMs and all of our fancy network middleware. We're going to put it on the drawbridge. And that's sort of how we're thinking about security. And what this lets us do, right, what this model is sort of letting us assert is outside bad, adversarial, low trust, inside good, vetted, high trust, right? The sort of castle walls and drawbridge are keeping us safe. And on the inside, what we have is a network that provides confidentiality and integrity, right? So great, we have this sort of simplifying model. And now how do we go about actioning it? How do we actually implement this model? Well, there's a sort of natural division of labor in terms of how we implement this thing. And it tends to touch at least these four teams, right? So when we talk about our security teams, what are they responsible for, right? They're responsible for defining the policies, defining the rules. Oftentimes, the rules we're talking about are firewall rules, right? So IP to IP based. And very quickly, for large organizations, that can get into the millions of rules. Right? And so where do our network teams get involved, right? Their job is to, as you might imagine, think about the network and sort of the topology around how does traffic flow, how do we design the sort of physical constraints of it. And so what they need to make sure is that the network flows traffic through the middleware, right? If we're doing a middleware-centric approach, the network has to constrain traffic in such a way that it's going through that middleware so that these firewall rules are effective, right? So we might define sort of zone A and zone B and segment those with a firewall, right? And so the physical network has to reflect that approach. And then our operations teams get involved, right? They don't really care necessarily about how the network, you know, was built, but their job is to deploy infrastructure, manage applications, you know, deploy the new version of a build, so on and so forth. And so what they have to be aware of is what's the correct zone, right? Where do I actually land this application, right? So we might say we have, you know, call it our application tier zone on the left, right, where our web servers and APIs, things like that are running. And then on the right-hand side, we have, let's say, our database zone, our data warehouse, things like that. So we're going to use our firewall, and in this case, segment between app and data. So where does that leave our development teams, right? Our development teams are responsible for application development, makes sense. But how do they relate to security, right? In this model, they sort of don't, right? The security has been transparently imposed for them, right? They're responsible for the app that's running in, call it zone A, but they're not really thinking about, hey, how did I secure access to my app? How did I secure access to the database? This problem was totally externalized on their behalf, right? And so this is what we mean when we talk to developers who are like, how do we make it approachable? And they're like, I don't think about it, right? They didn't have to think about it. So what's wrong with this model, right? In some sense, maybe it seems reasonable enough. Everyone sort of has their local thing to look at, and it seems to work okay. I think it really comes back to acknowledging that it is a model, right? When we talk about castle and moat, there's a set of simplifying abstractions that it depends on, right? And like any model, it's imperfect, right? And that imperfection comes from, inaccuracies in the assumptions we're making, right? So I guess the core question becomes, what are those assumptions that we're making that are allowing us to sort of omit enough concerns and simplify the problem into this type of thinking? I think the first big, giant, sort of glaring assumption is the threat insiders pose to us, right? I think the assumption of this model is that our insiders, whether employees, contractors, et cetera, the people we're granting access to sort of explicitly, are all trustworthy and have good intent, right? That's what this model is sort of saying, because in some sense, it doesn't matter sort of how tall the castle wall is if you're bad and on the inside, right? And so the reality is that's not a great assumption, right? In practice, what you see is that insiders are not universally trustworthy, right? And they're a major source of breaches and data exfiltration. The other thing is you have insiders that are actually not malicious. They're just, imperfect. Let's call it that, right? They're subject to, phishing attacks. Maybe they install malware at home and then bring their laptop to the corporate network, right? They get socially engineered. So it's not necessary that, I'm saying everyone in our organization is there, with bad intent and to exfil data. The vast majority of them are not. But the problem is, if, as any of us who have done sort of internal phishing tests against ourselves have sort of determined, it's an ugly picture, right? Even those employees with best intent, don't necessarily hold up against this type of attack. The second sort of big assumption around this model is really around the network integrity itself, right? So what we're asserting with this sort of drawbridge analogy is that we're doing perfect filtering on that drawbridge and letting us make this perfectly clear distinction between outside and inside, right? We've done an awesome, perfect job with our WAF and our firewall and our SIM. We caught everything. Everything bad is outside. Everything good is inside, right? The real world is not so quite a pretty picture, right? The perimeter is a lot more porous than we'd like to believe, right? Part of this is endpoint devices themselves, right? So workstations and mobile devices that are connected back through VPN. Those things have questionable security. Then you have our partner corporations that also have VPN connections to our data center, ourselves who maybe have multiple links of VPN between different sites, physical, cloud, things like that. And then, of course, there's bugs, right? Nothing is sort of perfect. So there's software bugs, there's misconfiguration of firewalls and other security devices. And really what all of this leads to is that eventually an attacker will get on network or on box, right? Either they're literally splicing your cable, or there's a remote code execution, or whatnot, but they will get onto the network, right? So this assumption that the network is sort of perfectly effective, that our filtering is perfectly good, is a bad one. And so what does that mean for this model in practice, right? In the real world, it turns out sort of two core assumptions, which was we trust our insiders, and so we don't have to worry about them being on the inside, and that the walls are perfectly secure, let us build this castle and moat analogy, right? But the moment you kind of strip those two away and say, actually the people on the inside, and maybe the wall's not as effective as we thought, then it turns out this kind of model starts to fall apart, right? So these assumptions might have been good enough for a while. And what I mean by that is maybe you have enough, small enough of an employee base that it's not a big deal, right? You say 1 in 1,000 employees are malicious, and we have 50 employees. Well, okay, maybe it's a good enough assumption that your insiders have good intent. If you have 10,000 employees, it's probably a really bad assumption, right? Someone didn't get the raise they wanted, and that person no longer has good intent, right? The other side of this is that as our networks get larger, right, it becomes harder and harder for us to assert the perimeter, right? If I have 5 nodes, it's actually probably not a horrible assertion that I can get my firewall rules perfect, right? I have 1 site, I have 5 nodes, it's not a bad assumption, right? As I get into, I have 12 data centers and 50,000 nodes, it's a really bad assumption, right? It's too complex for me to realistically say I'm going to get all of this right. And so I think the biggest problem is what we end up creating with a castle and moat sort of approach is an all or nothing defense strategy, right? We're saying either this thing is perfect or it's all bust, right? If I'm an insider on a soft network and I can access everything, that's not great. Or if I'm an attacker and I can pivot in at any point, right? There's one front door application with an out-of-date dependency and I can get on box, then this is sort of a critically bad assumption. And I think where we see this sort of as concrete examples in the real world is if we talk about something like Equifax, right? I think it's an easy one to laugh at, but at the same time, it could have been any of us in that similar situation, right? Because I think what you see is an application with an out-of-date dependency that's serving public-facing traffic. I don't know anyone whom that might apply to. Certainly not anyone in this room. And then you have an open network. And so all it takes is the ability to get to one of these application instances that is internet-facing, pivot onto that box, and now the open network allows you to get onto, sort of move laterally and get to things like databases. Same thing with the target breach, right? In some sense, it's ridiculous that you can hack Target through an HVAC system. You're like, how does that even possibly happen, right? But the fact that you have this sort of chain of networks that are all assumed trusted, all assumed confidential and high integrity is what lets you do the pivot, right? Once you're able to get onto the HVAC network, which happens to be connected to the store network, which happens to be VPN to back into the corporate network, and all of that network is flat, you're able to laterally move and get from an HVAC system to a database, right? So this, in some sense, flows totally against the grain of one of the most core tenets of security, right? Which is defense in depth. And I think this is kind of the strangest part of this whole model, is that somehow we've adopted this thing for sort of the gold standard of our networks, and yet flies in the face of the thing we know best in security, which is no one control is perfect, right? And so we want to think in terms of layered defense, such that it's not kind of all of our eggs in one basket. Okay, so it's enough sort of harping on that, right? What is the sort of path forward, right? What are the alternative models of thinking about security, right? Because I think, again, it comes back to how do we reduce the problem into something that we can think about so that it becomes tractable? So I think one model that's gaining popularity is the notion of zero trust, right? And the idea here is that we're not saying our perimeter is completely and utterly ineffective. All we're doing is we're acknowledging and saying, you know what, maybe it's 80%, right? That's not bad. I'll take 80% any day, right? But it's not 100%. And so what does that mean, right? If it's not 100%, that fundamentally means we can't trust it, right? We don't trust our private network or our insiders for that fact, right? And so this breaks our assumption, right? Because now the network doesn't provide confidentiality and it doesn't provide integrity. So what has to change in our approach as a result of changing this one assumption, right? And I think where this gets very tricky and why we talk about making it approachable for developers is that this model demands a lot more from our development teams than historically we used to. So the first part of that, right, and I think a sort of a common challenge that now comes into scope is secret management. So when we talk about secret management, when we talk about a secret, first of all, what are we talking about, right? It's things like database credentials, right? So database username and password, it's API tokens, it's TLS certificates. Those are all what we'd consider secret material, right? They're secret because if I know it, I can authenticate or authorize myself against an endpoint system, right? And so what you tend to see with secret material is that it's in plain text and it's everywhere, right? It's in application source, it's in configuration files, it's in config management, it's in version control systems, it's in wikis, it's on Bob's desk with a sticky note, right? It's kind of all over the place. And so the challenge with living in this sort of sprawled world is that we really have very limited authentication around it, right? Maybe there is single sign-on, right? So if anyone in my 10,000 person org can single sign-on, they can go to my GitHub, and great, they can see all of it in plain text. There's very little authorization around it, right, in this sort of sprawled state, because it's kind of all over the place. And many of these systems, there is no fine-grained authorization, right? It's not at a per file level who can go see it in GitHub. And then lastly, there's very little audit trail, right? So it's very hard for me to say who's accessed the database credentials in the last 24 hours, right? It's kind of like saying who's gone and browsed source code, right? I don't know. And so the challenge with that is, as we take a zero trust model, we need much, much better hygiene, right? Because now we're saying I don't trust my insiders, who could be anyone in my single sign-on domain, right? It's not acceptable that anyone in the SSO could go to GitHub and go read the database credential plaintext, right? That person needs a higher level of authorization. Plus, I want an audit trail. So what we'd really like to get to is a centralization of all these credentials. They can't live sprawled everywhere. They should be centralized. They should be encrypted, and they should be tightly access controlled, right? Now the challenge is, great, we do all of that, but our applications still need secrets, right? They still need to connect to the database. They still need, Amazon credentials. They still need TLS certificates. So our applications have to now play ball. They have to be a little bit more aware of these challenges. The next big one we talk about is data protection, right? So oftentimes what you'll see is that an application takes sensitive data, right? Credit cards, PII, social security, whatnot, and it writes it in plain text to storage, right? Databases, data warehouse, things like that. And on a very, very good day, what we might see is that the databases are using something like transparent disk encrypt, right? So we're using an HSM or a KMIT provider, whatever, so that we're encrypting the data that's leaving the database that it's writing to disk, right? The problem we have with transparent disk encrypt is it implies transparent disk decrypt, right? That's kind of how that works, right? So what we're really protecting against is someone physically walking into my data center, unracking a disk drive, and walking out, right? What we're not protecting against at all is someone connecting over the network saying, select star from customers, and the database will happily, transparently decrypt it, hand the data back to you, and you can go on your merry way, right? And so as an attacker, why would I bother, right? Why would I even drive to your facility? There's no point, right? We have these credentials, and these two are sort of tied together. These credentials are sort of sprawled everywhere. So why wouldn't I just go take the plain text database password, connect to the database, and ask it to decrypt the data and hand it over to me, right? So how do we start to think about solving this at an application layer? Well, the application has to encrypt its data and not transparently, right? Because if we have transparent encryption, again, it's going to imply transparent decryption. So the application has to, in some way, interface with either a key management system or a system that's offloading cryptographic sort of capabilities and explicitly go and say, please encrypt this data for me, right? Credit card data, whatever, username data, things like that. Please encrypt it, hand it back, and now I can go safely store it in my database, data warehouse, things like that. What this buys us, done right, is that now we need a two-factor compromise. It's not enough that you just found the database credentials and could connect to the database and say, select star from customers, because all you got back was encrypted data, right? It's not actually usable. So now you have really only two ways to get at it. One is either to somehow get a hold of the keying material. And this is why it's important that we don't give the keying material to the application itself, that it should reside within an HSM or sort of a middleware service, KMS, things like that, that are not actually going to give you the underlying keys, so there is no way to exfil that. And so what this forces an attacker, if they can't get to the keys, is an online decryption. They must stay on your network. They must have persistent access to the keying system, and they must go through and decrypt record by record, right? This is a lot more obvious, hopefully, to us than them being able to just select star and go on their way. And what this model gives us is strictly better than transparent disk encrypt, right? Like, if the data that we're writing to the database is already encrypted, then great, you can unrack the disk, walk out with it. It still doesn't help you, right? But now even if you connect to it over the network and say, select star from customers, it also still doesn't help you, right? So this is an approach that's sort of strictly better, but again, not transparent. Our app developers have to play ball. So our next problem is that we've allowed our developers, right, if we go back to sort of that zone-based model of thinking, to say, the network is actually dealing with giving us both integrity and confidentiality, right? I don't have to worry about it as an application developer. But this is no longer sort of a safe assumption, right? If we're saying, actually, my network might be compromised, attacker might be on the network, then we can't just assume the network is doing this, right? It's now the responsibility of the application and the developer to be conscious. And so what we start to need is a few different things, right? One, we'd like a notion of caller identity, right? Because saying IP1 is talking to you is not particularly helpful, right? I don't know who IP1 is. I don't have a good way to authorize IP1, right? The next thing is I want explicit caller authorization. Just because I know an API is talking to a web server doesn't mean the API should be talking to a web server, right? It should be explicitly authorized that there's some reason these services are communicating. And the final bit is if we don't assume confidentiality of the network, then we need to assert it somehow, right? So how do we actually encrypt application level traffic so that we're not depending on the network to provide this, that we're going to explicitly encrypt the traffic? So that was a lot of things that we're starting to bring into consideration for our app developers, right? And if we look at how we think about their existing set of concerns, it's a common set of things that we already talk about all the time, right? As an application developer, I need to think about SQL injection. I need to think about cross-site scripting. I need to think about, do I do password management correctly, or am I just putting their plain text password in the database, right? How do I do session management correctly? If it's an application that's multi-tenant, is the application implementing access control properly, right? So that users of org1 can't see data from users of org2, right? And so all of these are sort of naturally application level concerns because they sort of have to do with the logic of the application itself, right? So it's very hard for us to kind of take these off the plate of the developer. At the same time, we're now saying, okay, great, castle and moat is dead. We're going to move to zero trust. Here's a whole set of new fun problems for you, right? Now you also deal with secret management, data protection, auth-n, auth-z, traffic encryption. So, the challenge I have with this is we never really got good at the first set, right? And so now what is the sort of practical sort of impact of saying, we never nailed that, let's double it up, right? As, the odds are we're going to do this even worse. And I think the matter is kind of even, I think, more complex than that, which is as you talk to security, to sort of people outside of the security realm, what you find is that security is a really deep and really broad domain, right? And it's not particularly accessible to beginners. Especially the language we tend to use makes extremely heavy use of jargon, sort of on average, right? And so I wanted to sort of illustrate that so it doesn't seem like just kind of pulling this out. And so I said, let's just Google, right? I'm a Java developer. I want to encrypt some data, right? Common concern, I just said data encryption should be their problem. So I just went to Java's Java doc for Java 7 and looked at the Cypher class. And this is what you see right in the header, right? This is the core of the documentation for how a Java developer would think about, I should go encrypt some data, right? And so we might be looking at that as someone who is sort of versed in cryptography and go, okay, yeah, I know what this is saying. I understand what I need to do here. But that's because I can translate all of the three-letter acronyms that they're using in my head. I know what these things are. I know how they relate to each other. I know how you construct sort of a cipher, right? But assume I didn't know that, right? Assume I was coming in as, I'm a Java developer. I want to encrypt some data. I'm going to get to this page and be like, cool, I Googled encryption in Java. So my goal is encryption, right? And the first thing I get to is a cipher. What is a block cipher? What does that even mean? How is that related to encryption, right? What is padding? There's a whole lot of mention about padding, different types of padding. What is PKCS? How do you even pronounce that, right? And how do I use it, right? What is an AEAD, right? It sounds like a disease, right? I don't want that, right? And then all of the modes are only referenced as three-letter acronyms, right? So you wouldn't even know what to Google. You're like, oh, let me go see what a CM is. Let me go put that in Google. What's going to come? Nothing useful is going to come up for that, right? And so you're like, okay, these are super important. Make sure you pick carefully. Good luck, right? And then we're going to alternate between calling things an IV and a nonce. How are they related to each other? Are they the same thing? I don't know that, right? And so this is literally just like one basic thing, right? Cool, I'm going to go encrypt my data. It's literally impenetrable. I have no idea how to do this, right? And so what am I going to do? I'm going to sort of keep putting different values in there until this thing compiles. And guess what? Java will happily compile if you set your IV to all 0 every time. Not a big deal to Java. It looks great, right? And so what does this really tell us, right? It tells us that this is sort of horrendously inaccessible to the average developer. So this brings us to the concept of, again, sort of where this talk started. How do we think about making this actually approachable, right? So I think where this starts is really by acknowledging that it is not reasonable for us to make all of our developers security experts, right? Maybe an unpopular view, right? And I think we've gone through this road, right? Given sort of where HashiCorp sits in the space, we've gone through this with DevOps, where we said the idea behind DevOps, right? This is not what we said, but sort of the market is you get rid of operators. Your developers are your operators. That's what DevOps is, right? Brilliant idea until you realize your developers don't know anything about operations, right? It's a minor issue with this idea. And so now we're saying, okay, well, DevSecOps. We don't need operators or security. Our developers are all of them, right? Turns out, again, even worse of an idea, right? Because if you go out there and say, I want to find someone who's expert developer, expert operations, knows infrastructure inside and out, also cryptography expert, you're going to have a really, really hard time hiring anyone, right? And maybe that's okay. Maybe you only need one super employee, in which case, I'm happy for you. But for the rest of us, right, this is not a practical approach. So if we start and say, okay, we accept super developer doesn't exist, right? How do we actually start to solve this problem? And I think what it comes down to is sort of 3 different things. One is externalization of concern, right? Second is specialization of labor, which is kind of how we've always solved things. And third is practitioner education. So let's talk about each of them. So the first one is, how do we think about splitting the problem itself, right? How do we solve the problem at sort of different layers, right? So I think when we talk about an application, we have at least 4 layers, call it, that are available to us, right? At the very top, we have the application logic itself, right? This is what the developer is going to write. And the challenge is there's very limited reach in solving a problem there, right? If we're doing that layer, we have to resolve the same problem all the time for every application. Then you have application frameworks, right? These are sort of lower level. They're at least shared across broad swaths of application. Maybe it's specific to a language, but still, you get hundreds, thousands of applications on one framework. Then we have application middleware, right? It's a great idea. It's push the problem over the network, put an API in front of it, and now everyone doesn't have to resolve the problem, right? In some sense, it's sort of weird to think about, but there was a universe in which every company wrote their own database, right? It was like, oh, my data needs to be stored. I'm going to write a database, right? Today, that seems like madness. Like, no developer is like, I'm going to write my own database, right? You launch one, you talk to it as middleware over the network. And then you have your platform layer, right? And this is the broadest reach. Anything we can push to the platform, we sort of now inherit for free on all of our applications, right? So we got our broadest reach, the further down we can push where we solve this problem. So if we go all the way down and talk about the platform itself, right? Things like Kubernetes, things like Nomad, right, et cetera, right? You can even think about the clouds in some sense as providing a platform. What they're giving us is a very low level of operation, so we can't push business logic there, but we get a very broad reach of solving common problems, right? And so some of the ones we should think about at pushing down to that level are things like secret management, right? So do we really need every application to rethink about how they securely fetch credentials? Probably not. It's not that different by application. It's kind of the same problem, right? And then how do we think about auth-n and auth-z of service traffic, right? And so if we're saying, the network can't be trusted anymore, can our platforms at least help reintroduce trust? Can they sort of, coddle the application, if you will, and sort of solve this problem for us? So what might this look like, right? So if we talk about a platform layer, right, call this Kubernetes, that's launching sort of an application inside of an isolated namespace, what we might be doing is trying to provide things like secrets in plain text to the application. So the application, it boots, it reads its, whatever, config.json, and inside of that it has a database username and password, right? But practically, the secrets had to get there somehow. And so what the platform layer was doing is orchestrating this for us, right? It's orchestrating, talking to whatever our secret management solution is, getting it there, materializing it on behalf of the developer, right? So now as a developer, that concern has been externalized. I don't think about it. I read config.json, username and password's there. Great. How do we think about what the network used to do for us, right? It used to be that we said the network, all the traffic coming in is trusted. So your app, you just call accept, You process that transaction, you're good, right? Don't worry about it. So how do we get back to that? In some sense, it might not be solving it at the network layer. It might be another process on box that's sort of wrapping that traffic and shielding the app, right? So an approach we're increasingly seeing is things like service mesh approaches, right? Where I might have a traffic proxy. It's actually the thing listening on the untrusted network. But what it's doing is it's enforcing mutual TLS, right? You can't just be a random IP talking to this proxy. When you talk to the proxy, you present a certificate. You say, hello, I'm the web server. I'd like to reach the API. You do an exchange of certificates. You establish an encrypted channel. That's used to then call back and check, is there an authorization? Is there some rule that says yes or no? The web server can talk to the API. And if so, great, we'll terminate it and hand plain text traffic back to our application. So again, what does this let us do is from the perspective of the application, now I don't have to be aware of, okay, I have to encrypt my traffic. I have to get caller ID and sort of deal with authorization. I just accept my connection like before, process my transaction like before, and kind of go on my merry way. I'm, again, oblivious to the fact that the network is not trusted, right? So the platform is really giving us this opportunity to sort of shield the app and, again, externalize another few sets of concerns away. The other opportunity we have is application middleware, right? So tools like HashiCorp Vault, Auth0, AWS KMS, sort of there's many KMS providers, et cetera. These are network services that expose an API, right? And so for our developers, what this lets them do is sort of externalize a whole bunch of these concerns and not worry about getting them right? So with key management, maybe they're talking to KMS, and now they don't ever have the key. The app can't leak the key, right? They just talk to an API and say, great, I want to encrypt, I want to decrypt, I want to sign, I want to verify. They don't need to know what a mode is. They don't need to know what padding is. They're just like, here's some data, encrypt it. Here's some data, decrypt it, right? As middleware, do what you think is best, right? Much like a database, we're not telling the database on which cylinder of the disk to go right to. It's insert record, you deal with it, right? So how do we provide these higher level abstractions so our developers think about what's the set of APIs I need to compose? And they're relatively good at doing RESTful calls, right? They can reliably do that. But even things like username passwords, right? I think oftentimes we say, we get upset that you didn't salt it correctly, right? You didn't use the right sort of hashing algorithm, things like that. What if we go a step further and just say, just use something like Auth0? Don't even think about it, right? You're going to get this thing wrong. You're not going to stay sort of crypto agile as the sort of algorithms evolve. Just outsource the problem, right? So when we can, where do we look to middleware to sort of move these problems off of the plate of our developers and onto the plate of services that are specialized, right? Same thing as we talk about data protection. How do we outsource that? So one of the common things we see, for example, with Vault is specifically looking at that sort of data protection case, right? So where this started for us was what we often saw was Vault being used for secret management, where people would just store an AES key and then hand it out to the app, right? And once we saw this enough, it was like, okay, well, what's the assumption here? The assumption is that the app is now going to do the cryptography correctly, right? And it turns out that's a horrible assumption, right? So we're handing this key out to the Java app that's setting its IV to 0 every time, and then it's doing its AES encryption and writing out to disk, right? Well, great. That didn't really help us that much, right? And then if we talk about how many of these custom applications do key management correctly, right? Where we talk about key versioning, key rotation, key decommissioning, it goes from like slim to exactly none, right? So our goal was, how do we instead give you a high-level API where you say, I'm going to define a key, right, called the credit card key, and now I have an API to do encrypt, decrypt, sign, get random bytes. We have one customer who literally didn't trust their developers to get random bytes. So their ask was, can you have a Vault API that just returns random bytes? You're like, just call this kernel and ask for secure bytes. They're like, we don't trust the developers, right? You're like, so it's to that level where you're like, okay, well, I mean, sure, we can add an API if you think it's easier to call that. And so the goal is really, how do we get to the point where you don't need to know what is AES, what's GCM, what's an IV, et cetera, right? As a developer, I know, cool, I want to encrypt, I got a credit card key, I'm off to the race, right? That's accessible. Then as we go sort of one level higher on the stack, we get to frameworks, right? These tend to be super opinionated, they're language specific, right? Things like Rails, things like Django. But the nice thing about these frameworks is they get a guard against many common application logic issues, right? So cross-site scripting, SQL injection, proper session management. Oftentimes they have libraries to help with things like access control. How do we sort of push these out of saying, hey, developer, you think about doing all these things right, to instead saying, hey, developer, can you pick from one of these 5 frameworks that we know does this right? And now you don't have to worry about it. Just pick one of these 5, right? And so that brings us to the very, very top, right? Back to application logic. In some sense, this layer is always going to be vulnerable to logical bugs, right? Because it's sort of implementing the business logic itself, it's up to that app, right? If I can have the ability to share a file, whatever, between 2 organizations, sort of logical organizations in a multi-tenant system, that logic could always screw it up and share it with a 3rd organization, right? So we're always going to have those types of bugs. But how do we get rid of all the other class of bugs that in some sense are not that special? They're not related to the application's logic, right? So what we'd like to do is avoid reinventing the wheel as much as possible. And so what this turns into is everything we've talked about, right? It's consume APIs and middleware anytime we can. It's push it to libraries and frameworks. And there's a particular class of issue, right, that I think we're sort of maybe is less relevant for most applications is how do we move to safer languages, right? I think luckily, there's not a lot of applications being, written in languages like C, but how do we increasingly invest in things like Rust, where we get stronger guarantees from the language, where it's harder to have those sort of class of issues that we had with applications like C. So this brings us back to sort of our division of labor, right? We said we're not going to find our super developer, so how do we think about, dividing the problem once again? And I think largely it's going to be the same groups, right? So as we talk about security teams, they're still responsible for policies and rules, but the goal is how do we move away from thinking about sort of firewall rules and instead talk about logical service, right? So instead of saying, IP1 can talk to IP2, how do we say web server can talk to database? Because if we move the kind of rule set management out of the IP, then we move from a world where we're managing millions of rules to managing thousands, right? You're just not going to have millions of web server to X rules, right? It's sort of an artifact of the fact that I have 50 web servers and 5 databases. So great, I have 250 firewall rules, right? That explosion comes only at that sort of physical level. The next part of this is how does our networking teams interact, right? They're still responsible for the network topology. That doesn't magically go away. But in some sense, we're now saying, we don't expect the network to provide confidentiality or integrity, right? So we don't need the internal of the network to be constrained through middleware, right? Yes, the front door, we still should use the firewall. The perimeter is still 80%. But as we talk about east-west traffic, how do we move more towards zero trust and simplify our internal networking, right? So we don't need sort of an insane zone architecture. And this is really only enabled if we get to a place where the applications don't assume the network is providing integrity. Otherwise, we're still left with that constraint. As an ops team, I have, again, the same set of responsibilities, infrastructure and application management. But now, here's our opportunity to integrate deeper into the platforms, right? So as an ops group, if we're operating and providing the platform, how do we do things like integrate secret management, provide facilities for data protection, push traffic filtering onto sort of the endpoints so that as the application developer, they don't think about it, right? They're not thinking about how do I authorize traffic. As platform engineers, we're sort of wrapping the app and doing it for them. So that brings us to our developer teams, right? So they're still responsible for developing the application itself, but what we want to do is encourage them as much as possible to use frameworks, use security middleware, use platform features, as opposed to reinventing this at the application layer, right? The other part of this is it's important, I think, for everyone to understand the threat model, right? If our threat model truly is castle and moat, then great, we should all be aware of that. We should all understand what is the trade-offs inherent in that model and accept those if we want to go down that route. If we're not going to go down that route and we say, let's say zero trust is our model, then it's still important for developers to know that. They should still have an awareness of what are these concerns, right? And so as much as possible, they can then think about, great, I know this concern exists. How do I externalize it, but without it being totally transparent to me? And so the last piece of this becomes practitioner education, right? We will have a specialization of labor, so it's not reasonable that our developer is going to be, a super security expert, but we want people to be a T-shaped specialist, right? Meaning they have some little bit of depth, right, across a broad spectrum, but then go deep, right? My security team, they're deep in security. My development team, they're deep in application development. But we have sort of an awareness of what are these sort of adjacent things so that we have sympathy for one another, right? Because if we don't, we end up with security teams telling developers, hey, go encrypt your data, go read the Java docs. Well, that doesn't show much sympathy for the application developer, right? And likewise, if we're sort of a development engineer and we say, you solve it at the network layer, it doesn't show much sympathy for sort of the problems we face when we try to do that. And so I think this brings us to sort of teaching security, right? And I think the most important part of it is motivating the problem. What we often see is encrypt your data, right? It's a mandate. This is what the corporate mandate is. Versus if we can really prompt people, what you tend to find is most developers are naturally curious, right? There's a reason they went into application development. And so if you prompt them, right, if you motivate it, which is like, hey, you're writing plain text data. What happens? Our network's not perfectly secure. What if someone can get to the database, right? Sort of lead them to it versus the sort of mandate where they're like, yeah, whatever, right? And I think then for this to work, we need simple explanations. We need to be able to sort of ease people into this complex community. And I think that's an area where sometimes we have to let go of perfect precision, right? And I think, as a broader IT industry, we sometimes tend to sort of, overly punish people for imprecise statements. But I think what we have to recognize is that there's a time and place for being exactly accurate and a time and place where you need more descriptive power, right? And particularly when you're learning, when you're new to a thing, fully understanding all of the nuance is sort of irrelevant when you don't understand the general concept, right? It's how do we at least get you to the general concepts first, and then great, then we can flesh out what's the nuance, what are the exact details and caveats and sharp edges to this, right? But I think we have to be a little bit more accommodating to people who are new and trying to get into this area. So sort of wrapping this up, right? I think the challenge we face today is traditional security is very much castle and moat, perimeter based, right? And it's based on some simplifying assumptions that are wrong in the real world, right? And this has allowed our developers to ignore security concerns. I think where we need to go is really a model like Zero Trust, where we say perimeter 80%, not bad, pretty good, right? But it doesn't give us integrity or confidentiality, which means we need to think about all these problems. We need secret management, we need data protection, we need segmentation of traffic within the network, right? And I think as we think about the sort of challenge for an application developer, it's impractical for them to assume even deeper expertise and even more sort of problems that they have to solve, right? So how do we get there? We got to make them security aware, right? Make them T-shaped, but embed these things into platforms, right? Externalize to frameworks, use services, use platforms, and lean on the specialization of labor, right? DevSecOps as unicorns, not going to work, right? And this really hinges on us getting better at practitioner-oriented education. That's all I have. Thank you guys so much.